Test. Okay, party people. If you're here before you get seated, grab it now. We'll get started in about 2 minutes. All right, thanks. Are we ready? All right, how about a round of applause to get it started? Okay, welcome to Analyze Boulder. I see a lot of faces I know out there and a couple of hands who have been here before. Wow, nice. And who is a new person? Okay, everybody who raised their hands when I said who's been here before, keep your hands up, new people. These are the people you're going to go and you're not new. He's just trying to get attention. These are the people who you're going to go and introduce yourself to at the end when we're all drinking the rest of the beer. We have a pretty good turnout tonight, but I vastly overestimated on our beer order. So I expect everyone here to drink at least 3 beers, okay? Are we all in? All right, good. He's in, I think. Okay, well, first of all, we always like to start with thanks, and the first people we always thank are you guys. Thank you for coming. Big round of applause for yourselves. All right, organizers, I'm Justin. I didn't know I was going to be MC tonight. Tony in absentia apparently let us know a few days she wasn't going to be here, but I didn't see the Slack notification, so here I am, caught a little unawares and off my guard, but we'll make it work. And then, of course, we have Jennifer in absentia as well. Those of you who have been here for a while probably know her. Over in the corner, we have Greg. Round of applause for Greg. He keeps our AV running smoothly. He's the guy who's going to be running around with the microphone. And then Eric, right here, your beer guy. Huge round of applause for beer guy. Eric also he has a pseudonym. It's Vanna White, because he's going to be over at these boards later, writing down your jobs. And then, of course, Galvanize. And Danielle, you want to come up and say a little something? Round of applause for Galvanize. We love these guys.
Hello, I'm Danielle. I'm the community coordinator here at Galvanize. And just want to say thank you for coming in and using our space here. If you're wondering what do we do here, we've got a coding school upstairs, we've got a co-working space, we have events, so just like this one. So I just want to kind of shout out a few events we have upcoming. On Friday, we've got a Learn to Code Python here, and then on Tuesday, we've got an event called Chocolate Cheese and Coding for Moms. So if you know any moms that are looking into getting into coding, have them sign up. And also, at the end of the month, we've got a founder hour with Mo. Seigel, yep. Let me see. Yep, Seigel, he's the founder of Celestial Seasoning. So he's going to be in talking about his journey and how he built that. So yeah, just want to say thank you again. So we'll talk later. Thanks.
Thank you, Danielle. Okay, and then lastly, huge thanks go out to our speakers. Applause for them, please. First, we're going to have Bill Anderson. Bill is an old-timer. He's been with Analyze Boulder for quite some time. He's going to be talking about machine learning and cybersecurity breaches. Then we'll move to Rachel Stevens. She, believe it or not, named her baby using data science. That's pretty cool. Rachel, is he named Data by any chance? That's terrible. Did I just say that? Never mind. And forget I said it. Ben Robertson talking about rodent movement. And then at 7:45, we're going to move back to beer. Speaking of beer, I see that those beer, whatever they're called, I'm sorry. Damn it, Tony. Put money in the thing. All right. get connected, find us on Slack, analyzeboulder.slack.com. If you're not in the community, you need to email Tony to get in. That's uxtony@gmail.com. And then LinkedIn, best way to find us on LinkedIn is just to search for Analyze Boulder. Honestly, you don't need to worry about that URL. And then on Twitter, @AnalyzeBoulder. Who has events? Raise your hands.
So I'm here to talk about Go Code Colorado, which is a challenge sponsored by the Secretary of State's office asking people to use state-published data. Who here has heard of Go Code Colorado? Good. So you should come participate. So we're going to be here again April 13th, 14th, and 15th. You can find the team on Friday, build up an idea on Saturday, present on Sunday. This year, new to the event, top 10 teams win $2,500 in just straight prize money, no contracts, no mess, just $2,500 for each of our 10 finalist teams. And then invited to a venture weekend in Boulder, and then a final event in June where we'll give away an additional $15,000 to the top 3 teams. So really find a way to use state published data to add value to businesses. We'll have 5 events in Denver, Fort Collins, Colorado Springs, Durango, and Grand Junction, and 2 teams from each location. Right now we have about 175 registrations, about 115 in Denver, 7 in Fort Collins. So you guys should come participate, be one of those 2 winning teams, and have a good time. So gocode.co to learn more or participate. And then we'll also be hosting an info session with City of Boulder Innovation on March 29th as well. So you can learn more about the event then as well. But basically April 13th, 14th, and 15th, gocode.co, come participate, meet some people, build a product, win some money.
GoCode, awesome, thank you. Next event.
Hi, my name is Nicolaya. I work with the City of Boulder. I will actually be at that event. I'm helping organize that. So I work on anything related to analytics and innovation at the city, and we're doing a really cool art of data exhibit. The open call just went out on Monday. And the whole concept is using our open data catalog and other public data as inspiration for artwork. And we're teaming up with the Boulder Library. We're going to have a big gallery exhibit. So if any of you are artistically inclined or have friends or colleagues who are into art and data, it's a good combination. The open call goes through May 31st. And the open call is just for having the idea and the data that you're using as inspiration. And then accepted pieces will get $250. We have a website. I didn't write up the URL, but essentially if you search for art and data, City of Boulder, there's tons of websites that come up. And also, I'll use some of my business cards here because I'm sort of the main friend of contact if anyone has questions. We have some info sessions. But yeah, it'll be a cool event. So hopefully some of you will submit.
Sounds great, thank you. More events. Sure.
My sister organization of Analyze Boulder is Data Detectives. We've been 5 years now with the BJ's Wednesday, 11:30. Last 4 Wednesdays, we've been looking at business and practical aspects of UT learning, neural networks in particular. And several of us have gotten through the Andrew Eads specialization by Coursera. And we're now sort of scratching our heads and wondering what to do with this stuff. It's very fascinating, but is it practical? So we've been getting into a lot of good discussions there. If you're sort of gotten into deep learning, know how to spell that, and would like to participate in the next step in terms of practical applications, come and join us. Pick up my business card, this sort of thing. Data Detect is also a LinkedIn group, so you can just search for Data Detectives Boulder and LinkedIn. Richard Packer.
Really great group. I can strongly attest to how much fun it is to have lunch with these guys. So thank you, Richard. More events. Going once, going twice. Okay, let's move to jobs. I'll go ahead and kick it off. So SnappySoft is my company. My name is Justin. I am the president, and actually I'm looking for an assistant. That person needs to be a project manager. I do a lot of the project management in the business, and frankly, we just have too many projects for me to keep track of. So I'm looking for somebody with a strong custom software background in project management. If you have your PMP certification, even better. But basically what you will be doing is, of course, interfacing with our clients to get the requirements from them, passing those off to our developers, and then overseeing the process of developing the software itself. So the other job we have is for a mid to senior level developer office here. That person's going to be working with our senior developer named John. He's really, really good at what he does, and as a consequence, we have him doing way too much work, so we need somebody to back him up. We are a Microsoft.NET shop. We work on Azure, and really what we're looking for is somebody who can work in Azure, knows MVVM really well, Knockout, Bootstrap, and Require. So if you are interested in either of these positions, please get in touch with me. It's justin@snappysoft.com. It's not spelled like it sounds, SNAPI soft.com. Justin@snappysoft.com. Who else has jobs?
My company, I work for Ohio, based in DC, and just all 4 employees in Colorado right now. But we are hiring for a Tableau developer, data analyst. Probably working
Email you or find you at the event?
I'll find me at the event. You can email me. I'll post something on the chat.
Okay, perfect. More jobs. Who's got them? Or if you want them.
My name is Angela Zaluka. I am a programmer all around. I learn things very fast, so I'm interested in data science, data engineering analyst, Python developer position. I previously worked for NASA. I am now looking to transition industry, and I worked for a program called Data Incubator last fall. And I gave a talk here in January about the Boulder floods, and I'm very interested in speaking to you.
I'll start running around. You wanna? All right. Next job.
Hi, I'm Devin. I'm from Mozilla, and we build Firefox. We're looking for senior data analysts. So if you're interested in driving a big product, we have some roles up at the boat. Is it Devin?
All right, thank you. Next job.
My name is Peter. I'm a PhD in applied math. I'm going to graduate in May. I study anomaly detection and network data. I also work in ad tech, network finance around town. I do Python, sort of the whole machine learning stack, scikit-learn, pandas, TensorFlow, all that good stuff. Spark and SQL. So I'm looking for what's going to happen after graduation. So, I'm talking.
Peter, do you know anybody who's gotten a job here?
Yeah, my girlfriend got a job here.
That was a rhetorical question, thank you. Thanks, Peter. All right, next job.
I am Chase. I'm a double major at CU in information and technology, aspiring data scientist. I have experience in data analysis, visualization,
Great, thank you. More? Going once, going twice. Okay, we're going to bring Bill up here, our first speaker. Big round of applause for Bill.
you hear me okay? Great. Yeah, so I'm Bill Anderson, and I'm going to share some information about using machine learning to enhance cybersecurity. Now, in 5 minutes, I can't go over all the details, but I'll give enough information that hopefully you'll have a good sense of it. So cybersecurity breaches, as I'm sure you're probably aware, are happening all the time. Credit card fraud. I'm curious by a show of hands here, how many people have not been contacted by their credit card company about potential fraud? Okay. Okay, we got one in the front row. Okay. Equifax, the credit reporting bureau, was hacked last year. A lot of government agencies, Target, and so forth. So my organization has over 100 petabytes of data with hundreds of millions of objects. This data is valuable to us and hard to replace. What if someone is authenticated and authorized to our system, but maliciously removes files? How would we detect that? Most security software checks for specific known threats, such as this virus signature or malware signature, or this network port is open when it shouldn't be. What if none of those conditions are true and someone has legitimate credentials, but maliciously removes files? Traditional security software usually won't detect this type of problem. So we decided to take a look at our object removal data just to get a sense, are there patterns there, what's normal, and so forth. We looked at all the object removals on our system for all the 3-hour intervals over a 3-month time period. For each of those intervals, we counted the number of removes. That's important to us because if there's a very large, unusually large number of removes, we may want to investigate that. We also counted the number of unique clients that have removed objects in each interval. That's important to us because a lot of removes by one client might be anomalous, whereas a lot of removes by many different clients might be normal. Here's a plot of that data for a particular 3-month time period. Let me see if I can get the pointer here, okay. So the x-axis is the number of unique clients that removed files. The y-axis is the number of removes. Each of those data points is for a 3-hour interval. So you can see it's pretty unusual to have more than 300,000 removes in a 3-hour interval. So we looked at this data across multiple different time periods, and we did see there are some patterns there. So given that there are these patterns, we realized that machine learning is a tool that can help us. So we use something called k-means clustering to detect anomalous removal patterns. And as a very first step, we're using the 2 attributes that I just mentioned on the previous slide, namely the number of removes per time interval and the number of unique clients. This is all done in Python and scikit-learn. It's about 500 lines of code. It's not difficult to do if you're so inclined. I know there are commercial products and other tools out there as well, so it's not difficult to do this kind of thing. Here's that same plot, but in addition to the data, I've plotted the k-means cluster centers here. Those are the blue crosses. There's 5 of those. The one at the top is designated as the anomalous cluster. Why? Because there are so few data points associated with it. So this represents the cluster model. So how is this used going forward? Well, on an ongoing basis, we're collecting new data. Each new data point is assigned to an existing cluster. So suppose a data point comes in up here, the closest cluster would be the anomalous cluster. In that case, we'd get an alert. In contrast, suppose a data point comes in down here, for example, there weren't many removes that occurred, that would be associated with one of the normal clusters and no alert would be triggered. So the key takeaways are machine learning can be used to help detect anomalies. K-means clustering is one machine learning approach that can be useful, and we're using this approach to enhance our cybersecurity. Thank you.
Any questions?
So it seems relatively easy to fall below the threshold of anomaly by tailoring your bot to do things at a frequent level. Is there some way that you would address that, or is there some different mechanism?
Yeah, so with this first stage, we're not addressing that, but you're right, that definitely is something that could be, you know, classified as normal with this current model. So yeah, going forward, that is something we will address though. Yeah.
How would you go about choosing 5 clusters?
Yeah, so, you know, a lot of aspects of machine learning are kind of empirical or heuristic. And with k-means clusters, the number of clusters is really up to, you know, you take a look at your data and so forth, and you kind of get a sense of how many seems reasonable to what you see and so forth. Look at that for multiple different sets of data. And then, yeah, you just kind of empirically choose a number that's not part of the algorithm per se. Yeah.
Other questions?
Think about number of clusters based on accuracy as opposed to just pure clusters.
We did try some different cluster numbers, yeah, so that was part of that process as well, yeah. Does that make sense? Yeah, that's a good question. So there are different approaches. So we chose based on the cluster that has very few points associated with, but there are other approaches too. For example, you could choose a cluster that you could identify points that are very far away from a cluster center, for example, and designate those data points as anomalous. There are other approaches, techniques. It depends on the data. So in our case, this approach worked well for us. Yeah. Yeah, so let's see, I'm trying to recall here. I think it was like 300 iterations, but 10 different centroid seeds, you know, were tried. Yeah.
More questions? I have one. How did American Express know that I don't order Domino's pizza?
I don't know.
Totally amazing. 2 weeks ago, they called me. They declined the charge and called me and said, "Who's this week?" I might have that answer right now. There you go. Okay, thank you, Bill.
Thank you.
We have Rachel Stevens.
Hi everyone, I'm Rachel. By day, I am an industry analyst with a company called RedMonk, and by night, I am a new mom. And the night job has been totally overwhelming at times, but one of the things that I have found to be very helpful is applying some of the skills and processes that I've acquired over my career towards the art of parenting. So this is my totally over-engineered and really nerdy process for naming our daughter. So step 1 is probably familiar to most project managers, is requirement gathering. And like most project managers would probably tell you, it seems like it would be preferences we discovered. And so things like family name significance seemed really obvious, but then the more we talked, the things we realized were we didn't maybe want to have our child have the same name as a hurricane in 2022, or maybe we felt really bad for Puck in Midsummer Night's Dream, who could never banana fan of Po Puck at school, things like that. So we came up with a whole lot of things that were of varying degrees of importance, and we came up with kind of a list of guiding principles. And so once you have those guiding principles, you have to be totally prepared to compromise them. Because what we have discovered, and I don't know if anyone else had better luck than we did, but there's no name out there that is going to hit everything on your list of requirements. So you have to come up with your list of nice to haves versus must haves. And the more that you can treat as a guideline rather than a strict rule, the better off you'll be. So from there, project management, you're doing your call for proposals. This is the part where you're going to come up with the longest list of names that you can come up with that meets your requirements. And this is not going to work. But the things that you can do baby name books, that's traditional. There's tons of websites. And if this works, you could go through swiping right and left. There is, in fact, a Tinder for baby names now. You can download an app with you and your partner, and you can both swipe through names and discover what is on your matching list. So all kinds of technologically savvy options these days. Then this is the fun step. This is narrowing down the contenders. This is where all of your grade school grievances come out. I'm not going to name my child Ricky because Ricky stole my pencil in the 3rd grade. It's a good time. This is one that I do in a public third-party location where everybody can keep their tempers. Next step, now we're going quantitative. We're going to go first to Wolfram Alpha. It's a fantastic site where you can go in and put in your name, and it throws all kinds of fun facts back at you. You can get trending data, and they actually run that up against actuarial tables so that you can get births versus estimated deaths and get kind of a number of estimated people with that name and their age distribution. It's a lot of fun. But we are Analyze Boulder, and Wolfram Alpha is not enough. It is not enough at all because we are pirates. Arr! We are going to go in-house with R. So my nerd hero, Hadley Wickham, has created a package called Baby Names, and it gives you 135 years of Social Security Administration data. So you can go through, you have 1.9 million observations, almost 100,000 unique names, and you can do a whole bunch of trending. And you may ask, why do I want to do this instead of Wolfram Alpha? Great question. So I thought, for me, I wanted to track multiple names at once so I could kind of do trending comparisons in the same chart. I wanted to do regex, which is maybe the first time anyone's ever uttered that statement, but I wanted to compare different spellings and iterations of the name at once so I could get a sense of overall popularity. So for me, for Rachel, R-A-C-H-E-L versus A-E-L, and then I could get a sense overall. And for us, we were interested in gender neutral names, so looking at different things like if you're looking at a Samantha versus a Samuel, and I wanted to care about how many Sams might be in a class, I could combine the both gendered names. So that was what we did for our in-house, but you can't do all naming quantitatively, but that doesn't mean you can't use Excel. Final step, you bring it all together for a qualitative decision matrix. You go through and come up with all of the different categories that you've cared about and considered, list out your final contender names. And like most IT projects, ours was way longer than we thought it would be, and we definitely missed our deadline. It took us 24 hours in the hospital to finally come up with our final contender. But this is my daughter, Alex. The thing that we liked about the name was that it was gender neutral. We thought it kind of hit the sweet spot of popularity where it was not overly popular, but as common and understood. Some of the concerns we had was indeed that 2022 hurricane that's coming up potentially, depending on tropical storm strength. And we had to rename our Alexa to Echo. So there are pros and cons to every name, but we felt pretty good about Alex. And so now we're on to our next and new baby challenges.
So is this Hurricane Alex that you're talking about, or Hurricane Alexandra? You know there's a Hurricane Alex in the cycle.
It's Alex, yeah. We call her Alex. That's, no worries.
How many languages did you choose to include?
So a lot of my data was US based and it was almost entirely English. So we looked around at some other kind of, French was one that we looked at some, but mostly it was English based.
Have you thought how you're going to explain 20 years why you're making that?
Well, luckily this will be recorded, so I can just point right at that.
That's the best answer we've ever had.
We did very similar thing before our daughter was born. And initially, we really liked the name Olivia. And we found out there are a lot of male Olivias actually in the assistance data center. Have you found anything like that? And did you eliminate some of those outliers? I don't know, male Olivia, if their parents really wanted a girl, or it's because of some mistakes. Are they doing reporting?
I think that's a fantastic question. I think the one that caught me off guard, and I have to watch myself because I don't know what everybody is named in here and what you all have loved ones named, but there's a surprising number of people named Paisley, and there are an amazing variation on spelling of that name. Lots of Paisleys. That was the one that surprised me.
Next question. Anybody back here? Anybody back? Twice. All right, big round of applause for Rachel. Next up, Ben Robertson.
Okay. So, okay, we'll just have to deal with that. Stop sharing. Good.
Okay, we're sharing. Round of applause for Ben. Thank you.
Hi guys. Yeah, this is going to be a little bit different than a typical talk here because I'm going to talk a lot about both how we acquire a lot of data and then how we analyze it at the same time. So the first question that I get all the time when I present this is, why did you pick rodents? It's basically because every preclinical model of disease is in rodents, including all of the neuromuscular disorders. There's a whole laundry list of them here. And unfortunately, even though movement impairment is a primary issue with a lot of these disorders, nobody studies movement in rodents in all these preclinical models. So why is that? So it's because rodent motion capture is quite hard. The first problem is rodents won't wear motion capture markers. Most motion capture markers are adhesive. The way you actually test if an animal has a sense of touch is you put a piece of tape on its paw and you count the number of seconds until it rips it off. So adhesive markers are a non-starter. When they do move in the markers, they move very strangely. So it's not very valuable information. And then they do pull the markers off and they need to be constantly reapplied. That introduces a lot of error. And then another problem is rodents don't follow verbal commands. They don't take orders like dogs. And when they do perform whatever behavior you're waiting for, they do it really rapidly and they do it really sporadically. So waiting and trying to hit a button is really not great. So what is required for robust motion capture? So motion capture in general, you need synchronized cameras, you need a calibrated capture volume. And then in the case of rodents, when we were designing this, we decided we wanted behaviorally triggered automated capture, and we wanted to have a non-invasive, non-adhesive, semi-permanent body marker set. So the first step in this is just synchronizing our cameras. I'm sorry if you guys can't see the schematic very well, but there's some green lines and some blue lines. Those are the important ones. There's some red lines, sorry. So we have 5 cameras set up at various orientations, and these are all triggered digitally through a voltage trigger by an Arduino Uno running a sketch or a program called TriggerBox put out by the Straw Lab at University of Friedberg in Germany. And so we know that all these cameras are being told to capture image at the same time. I'm sorry, I should say that capturing images at the exact same time is incredibly important in motion capture, and I'll explain that in a second. But one of the problems with this sort of digital transmission of data is sometimes you drop frames. And if your frames get desynced, you're in a lot of trouble. So as a way of sort of backing this up, these are all Linux systems. We have computers running our cameras, we have computers running our behavioral analysis, and we slave the clocks on our camera computers to our behavioral analysis computer using a PTPD2, or the Precision Timing Protocol daemon, and that way we can realign frames in post-processing if we have to. So the next thing we need is a way to calibrate our capture volume to generate something called a direct linear transform that I'll talk about more in a second. But it requires multiple markers with really well-characterized orientation, geometry, size, everything like that. So we chose Legos. They're really well machined, and they cost pennies. So once you have this nice little marker set, and you know the location of all, in this case, of our white dots, we generate this thing called a DLT, which basically is a way of saying, okay, if I'm at position UV in the image plane, I can generate a ray that goes out into 3D space, and I know whatever I see is along that ray. And then if you have a second camera that also captures this exact same situation in time, you find that exact same feature or object, and you project a ray through it. Now you have two rays. You find the minimum distance between them, and you have an actual 3D location. So that's why the synchronization is really important. The next thing we want is self-selected and automated capture. So this is kind of the schematic of our system. So it all starts with this overhead camera. It's a grayscale camera. We do some contouring and some thresholding, and we find the center of our contour that's roughly black and mouse-sized. And then we run it through a Kalman filter so we can predict position and speed, and then we can update our treadmill belt speed accordingly so that they get to move at a self-selected speed. We're also logging these speeds. Once they've engaged in our desired sort of behavior, we can actually capture video. So we're storing all these in a ring buffer, and whenever we get a desired behavior, we just dump the buffer, and otherwise we're not saving anything to disk. I'll have to fly through this. So the last thing was the non-invasive markers. We chose hair dye. We had color hammers. Doesn't wash out. They're white rats or black mice, works great. You can do some really nice image segmentation. You can get identify these features pretty automatically, pretty robustly. We used some super pixel-based segmentation and support vector machine-based tracking to actually track these markers. And the end result is something like this, where we actually can track these markers and generate a rendering of what these things are doing at their joint level and get a really good idea of how they're moving. And at a level of detail that really isn't possible with a lot of commercial systems. And I think that's about all the time I have, but I'll just let this keep playing. It's actually a pretty cool video. And I guess I'll take any questions you guys might have.
So with most common filters, syndrome manipulation all the time, you can go into definitions. What's your sample rate?
So for the actual real-time tracking, if we have a real-time video display like I showed here, it's about 30 hertz. If we're not doing that, we can get between 80 and 100 hertz if we don't have a real-time display of it. But the cameras themselves actually capture at about 250 hertz. So the actual motion capture cameras are running at 250 hertz, but the behavioral detection is running at 60 hertz. So a mouse typically runs at about 10 hertz. So, and we're just trying to capture them at steady speeds and things like that. So 30 to 60 was more than sufficient for our purposes in this case.
I wish that this was around 5 years ago when I was doing animal models. The system that we have tracked mice that very well.
Well, yeah, this is it's a problem that I think nobody really cared to solve for a while. And it wasn't until we really started digging down on how to really robustly track these things and trying to track, trying to correlate rodent behaviors with pathological movement patterns that we would typically see in a person, that we realized that the resolution is it's terrible. It's really bad for a lot of these conventional systems. And so yeah, this was about 2 years, but it was totally worth it when it came down to it.
Yeah, what kind of discoveries have you correlations
So actually, this video here, if you knew how rodents normally moved, you would know that its tail is in a very odd posture. So about 4 weeks before I took this video, I completely paralyzed the hind right limb of this animal, and then used some experimental techniques that I developed to actually restore locomotion. And so one of the things that we tracked in this that has really not been tracked ever with rodent movement was just how many times it initiated a step by dragging its foot on the ground. So stroke, spinal cord injury, a lot of movement disorders, one of the biggest problems they have is they just can't get their foot high enough off the ground to reset it. They trip, they fall, and it's just a really nasty cascade from there. And so using this system and just looking at this at the high sample rates that we have, we were able to figure out that we actually reduced the incidence of foot drop by about 50%. We've also done some studies in mice. One thing I didn't talk about with this was sometimes when they do the right behavior, we actually fire a cam up from out of the belt and trip them. So that was part of a project with the Army Research Labs, and the idea was to identify what the controller is that allows a quadruped to remain really robust and stable in uncertain environments. And so from that, we found some really interesting sort of phase-based controllers that, you know, typically you would think, hey, if I trip, I'm going to go to a walk. I'm going to slow down. I'm going to do something that's a little more stable. But it turns out they actually go to a bound. They go to something that's incredibly mechanically unstable and is really good for acceleration. So we figured out that instead of trying to coordinate their limbs, they try to just maintain center of mass velocity and not, you know, not eat it. So there's been a lot of fun stuff that's come out of this.
So you're just going to use this in your lab, or are you going to sell this?
We'd like to make this open source. So a lot of people who do this kind of study, they don't have the expertise to develop something like this. A commercial system like this can cost between $150,000 and $250,000, which a lot of university labs just don't have access to that kind of funds. So we built this for about $10,000, using off-the-shelf parts, using open source libraries. The only thing that wasn't open source was a few things done in MATLAB, but most universities have a MATLAB license. So we're actually, this paper's been submitted. Hopefully it'll be published soon, and when that happens, we'll make our GitHub repo public and try to make this accessible to everyone.
All right, fantastic, thank you. Really cool work. So we have worked for a little while. We have, from what I can tell, a whole bunch more beer over there, and we even have a ready-made icebreaker for you. What's more important, data or metadata? And go. Thank you for being here.
Thank you. Yeah, I just had to.
Very nice and very nice person.
Thank you.
Interesting.
I'm glad you liked it. I enjoyed yours as well. That was cool. Okay.
All right.
Huh? I have some cash on me. Well, I'd have to break a 10 to buy one beer, but hi.
That was really
I'm glad you like it.
Yeah, I really like it. Well, so I'm curious about markers. I've done a bunch of stuff in drone navigation.
Yeah.
So it's, you know, it's the same common or extended common filters for doing that kind of shit. And it looks like you had a really high density of markers. Why, for a 3-volume space, do you need such high density marker? I mean, it seems like with a very sparse marker set, you're good to go.
Yeah. So, I mean. So we were constantly, and so some of the markers go in and out of view, and you need a total of 11 for a really robust calibration using the methods we were using DLTs.
Now, since you had lots and lots of cameras because you were nervous about not capturing something in some location, or you were worried about resolution with respect to, you know, if I just have 2 cameras or 3 cameras.
Well, so one of the
because you know, like when you're doing drone navigation, you got a camera and you're just moving around.
Yeah.
Right?
So one of the kickers with this is the animals are kind of going to do what they want, and if you can't see every marker in at least 2 cameras, if you can't see a marker in 2 cameras, then you can't give it a 3D position.
Okay.
So you need to have enough redundancy in your camera system to make sure that basically, unless the animal just does something totally bizarre, you're going to be able to see.
But you already know what the space looks like. I mean, it's not like the space is changing.
It's very, and so when we start tripping these guys and they start pitching and yawing and doing all kinds of strange movements.
difference between to their local positioning?
Yeah, yeah. I mean, so with that DLT transform, right? I was saying, like, you know, you've got this. Yeah. So if you don't have two simultaneous viewpoints, the best you can do is estimate where on a line it might be.
And low resolution camera or 2 low resolution or 3 low cameras across the entire space don't get you into the intersection.
I just want one leg. I really only need 2 cameras.
You're trying to get all of